Hello, my name is Janet Apita and I'm going to determine which column is more efficient by analyzing and comparing their resolution based on these two columns. The number of theoretical plates for component B was measured, and a higher number of theoretical plates indicates more efficient column. In my opinion, between these two columns, I recommend column 1 as the most efficient compared to column 2. Based on the calculation, column 1 has a higher number of theoretical plates compared to column 2, making it more efficient and providing better separation of component B. The resolution of an illusion is a quantitative measure of how well two illusion peaks can be differentiated in a chromatographic separation. Based on the calculation, the peak resolution for column 1 is 1.82, which demonstrates that the separation between components A and B is well resolved. In contrast, as shown is the result, the two analytes in column 2 are not well resolved and exhibit broader peaks compared to column 1. To conclude, based on the calculation and explanation, I recommend column 1 as the most efficient and reliable option as it shows well-resolved peaks with a resolution of 1.82 and sharper, narrow peaks compared to column 2.
Hi, my name is Edna Alicia Anachimiam with the metric number of 98765. I'll be answering for question number 2. The answer for question number 2 is based on the picture shown in the video. In reverse phase HPLC, less polar compounds elute first because they have a greater affinity for the stationary phase, which is the nonpolar C18 column. More polar compounds will interact more with the mobile phase and elute later. Therefore, the first compound to elute first is benzene. As a nonpolar compound, benzene interacts less with the hydrophobic stationary phase and elutes quickly. The next compound to be eluted is nitrobenzene. This occurs due to its stronger hydrophobic interactions compared to the polar mactocy group in mactosibenzene. The presence of the nitro in nitrobenzene makes it a strong electron withdrawing group, significantly increasing its polarity. Consequently, mactosibenzene is the last compound to be eluted in reverse phase HPLC. It has a mactocy group that acts as an electron donating group. Then, it causes the electron density increases on the benzene ring and enhancing its nucleophilicity. This results in stronger interactions with the polar solvents.
Hello there, my name is Aidan Nunda Dunson and I shall be helping to interpret part A of question 3, which is to identify functional groups in the following FTIR spectra for the given chemical structures. So on here, on the first one, we do have the wave number of 3023, which resembles the CH-sp2 hybridized carbon bonds, which shows and indicates that this is an alkene group. There's about like 5 peaks. Now, for the reasons is that the CH bonds in alkenes are slightly stronger and shorter due to the S character, which increases in bond stiffness, and this makes the vibrational frequency higher, placing it around 3020 to 3100 wave number. Now, on the second one, we have the CH-sp3 hybridized carbons in the alkyl group, which vibrate lower frequency than the sp2ch bond group. Now, because it has a lower character or S characters, make these bonds slightly weaker and longer, reducing the stretching frequency. This results in peaks in the wave number of 2800 to 3000 region, which for typically is for alkyl and CH bond groups. Now, for on the third, we have the C double bond C group, which is showing that in the cis2 octene shows the characteristics of stretching vibration due to its rigidity and bond strength. The stretching vibration of a double bond is influenced by its stronger bond energy compared to single bonds. This vibration occurs in the range of 1600 to 1680 wave number, with cis2 octene specifically showing a peak at 1660 wave number. Now, with that all being said, by connecting these peaks to the hybridization and bonding characteristics of each group, we can further explain how the molecular structure of cis2 octene is reflected in the FTIR spectrum. And that's all for this part.
Hi, I am Josephina. Now I will explain task question 3, identify functional group present and the interpretation of its FTIR spectrum. The compound we are working with is butanamide, which has the molecular structure CH3, CH2, CH2, C double bond O, and H2. It consists of an amide functional group, which includes a carbonyl group directly bonded to an amine group. At 3200 to 3500 wave numbers, we observe two peaks. These correspond to the symmetric and asymmetric stretching vibrations of the NH bonds in the amide group. At 2800 to 3000 wave numbers, we see several smaller peaks corresponding to the stretching vibrations of CH bonds in the acyl chain. At 1640 to 106,090 wave numbers, there is a strong sharp peak indicating the stretching of the carbonyl group. It is also important to note that these peaks arise due to the dipole moment changes during vibration. The amide group is polar, which increases the intensity of the peaks in the FTIR spectrum. In contrast, a non-polar compound will exhibit weaker peaks in these regions.